Hi! In the previous section, we learned about Docker Stack command, how to create our own Docker Stack, how to deploy and update a service using Docker Stack. In this section, we are going to take a look at Docker Node and Docker System. Docker Node. In this video, we are going to take a look at using constraints to deploy our services, labeling nodes, and node availability. So let's go to the command line. As usual, I rebuild my environment. I suggest you to destroy and rebuild again. Okay, let's run our eval. Until now, we used the Docker visualizer, but I never show you how to deploy the service. So to deploy the visualizer, we use Docker service create, we give a name, visualizer, we publish ports, and we use constraints. In Docker Swarm, you can use constraints to deploy your services. So the visualizer requires to run on the manager node. Why? Because the visualizer reads the Docker events on the Docker sock. So because of that, it needs to be on the manager. And you can define your services that needs to run on the manager using the constraint node.row == manager. You can use == worker. You can have other possibilities as well. But this is one way to run services on the manager. So if we check here, Docker Service OS, our service is not running yet. It's preparing. It's taking some time because the image is big. And now it's running. When we come here, we can see the visualizer and we can see all nodes that are part of the Docker cluster. And the visualizer is running on the manager. So this is one way, let's say, how you can spread your tasks in the cluster. Now I would like to show you the node information. When I use Docker node inspect, I can check the whole information about one cluster. In this case, I'm using self because I want to see the swarm one. I will use JQ because of the highlight. So you can see the whole information related to the cluster in this JSON. We can see it's the row, it's a manager, and we don't have any labels. So the two ways to spread tasks in the cluster is using the row of the node, or you can label your nodes. So for example, in which situation do you need to label your nodes? One good example is when you have a PCI environment. So the PCI environment has a lot of rules, and you can, for example, in your cluster, apply all these rules on few machines, and your PCI project should run on these nodes. Or, for example, you have Windows and Linux machines in your cluster, and you will label your Linux and Windows machines. And for example, when you want to deploy your .NET application, you say, okay, I want to use this label to deploy my Windows application on the Windows nodes. This is one example as well. If we check here, instead of self, we check the swarm 2, we are going to get the same information. In this case, the row is a worker. But okay, I want to use the names-demo that we used on the previous section as one example. So I want to label the swarm 1 and swarm 2. I will create a type called type equals app. And my names-demo is going to be placed on nodes that have the type app. And my MongoDB database, it's going to be placed on nodes that have type equals DB. So how we can do that? We can use Docker node update. So Docker node update -- label add. Then I create this type. This could be data center, this could be whatever value that you want to. I just use type as one example. So type equals app, and then I'm labeling the swarm 1. So if I come here and check swarm 1, I can see that I have the type app as one example. I will do the same with the swarm 2, and with the swarm 3, instead of app, I'm going to use as a DB. If we go to the visualizer, we can easily see that the swarm 1 has the type app, swarm 2 as well, and the swarm 3 we have the type DB. Okay, so let's deploy again our application. First of all, I will create the secret, then the network, and before we deploy, I want you to show which change I did in the API YAML stack. So on the services, for example, MongoDB, I added the deploy placement constraints. I want to deploy on the node .labels.type equals DB, and the names-demo, I want to place the application on the node .labels.type equals app. Then Docker Swarm is going to deploy on those machines for us. If we check on the visualizer, Docker is going to send the command to the nodes. It's going to download the image. Probably our names-demo it's going to failing and going to be rescheduled because the MongoDB is not ready. It's a big image. So until the point that MongoDB is ready, names-demo should die few times. As you can see, it's appearing and disappearing, and it's going to be rescheduled again. It's starting, now it's running, so the names-demo should start as well. Yeah, 1 is already running, 2, 3, yeah, all our 3 are running. So you can see it was spread between swarm 1 and swarm 2, the application. Good. Now I would like to explain you about node availability. For example, when we come here and check Docker node ls, we can see the availability is active. So imagine that you have to do some maintenance on your node, or this node is broken and you need to remove from the cluster. A good way to do that is to change the availability to drain. So you can use, again, Docker node update -- availability equals drain to swarm 1. And then what it's going to happen? the node is drained, so you can send commands and the node is going to resolve the commands, but you cannot run tasks on this node more. So for example, our application here is not working more because one of the constraints was to run just the manager. So consider our manager is not running more tasks, we can't see. But if we run docker stack ps and the desired state running from the API stack, we can see that the application, all the application is running on the Swarm 2. So all the tasks was moved from Swarm 1 to Swarm 2. And at 38 seconds and 2 minutes ago. Oh, no, this 38 seconds was the one moved from the 1 to 2. This is good. You can do your update or remove your cluster after that. For example, to give you an example, I will scale the API underscore names dash demo to 3 to 4, just to show you when you put a node in a drain, it also can receive commands, and our application is starting. And as soon as we want to put this node back in the cluster, we finish our maintenance or what we need to do, we can just type docker node update -- availability equal active swarm 1, and then we can check on docker node OS that the node is active, and all the tasks that was scheduled to the manager should run again normally. And you are going to see that all my tasks is still working on the Swarm 2 because Docker did not rebalance the whole the tasks running in a node after a node comes back. But in the next deployment, Docker is going to rebalance the whole cluster. In the next video, we are going to take a look at Docker system.